Good morning, sixth grade. It is Friday and we finished 2 weeks. Yay! Let's do a review from yesterday. We started talking about acceleration and how velocity and acceleration kind of go hand in hand. Velocity, again, is taking your distance and the time that it took, but in a certain direction. So if I use the example of a train traveling 100 miles per hour over the course of 2 hours going west, that would be an example of velocity because I used the keyword west. Now, if we look at acceleration, acceleration is the change in velocity during a period of time. So the faster the velocity changes, the greater the acceleration. And again, there are 3 ways that we can check that we know velocity is happening, and that is when it speeds up, something speeds up, when something slows down, or when something changes directions. And then again, when we are in a car, we want to make sure that our brakes work because we want negative acceleration, or we call it deceleration, to occur. That would be awesome. Otherwise, we'd have a lot of crashes everywhere. And again, in order for acceleration to occur, we have to have a force. And again, a force is that push or pull on an object. If I want that object to move, I either have to apply a force to push it forward, or I have to pull something to get it to go my way, or if I want something to turn, I have to apply a force to the outside of that object to get it to turn, just like in our little hamster here. That's a cute hamster. Then if we learned about friction as well. Friction is that force that keeps object from moving against other objects, and I showed you the video yesterday of the person being able to push the car no problem because his feet were on pavement and his shoes were keeping the friction. If I put that car inside a basketball court that just had the floors waxed, man, if you've ever run on a basketball court and you fall and it's like road rash on your knees and your legs because everything just sticks. But if the person who was trying to pull their trash can up the icy driveway, there was no friction, so it kept things very slippery, just like these examples here. Okay, now we're going to move on to momentum. Momentum is going to take velocity and acceleration. It's going to kind of combine them. So the mass and the velocity, again, velocity is speed and direction of an object determines its momentum. Now, who remembers what mass is again? Yep, that's right. How much matter is in an object? Okay, remember our mass does not change based on location. So my mass is the same as it is here on Earth, as it is on the moon, as it is on Jupiter, but my weight would change. So mass, again, is what is in me. The only way that I can change my mass is if I remove something or I add something to me. So like if I cut my arm off, I've just removed some mass, or if I lose a lot of weight, a lot of fat, then I've removed mass from my body. If in these, what is this called, this isolation time, I continue to eat all the food that I want to eat, I'm going to come back to school with a greater mass. Don't laugh at that. So this concept could sound complicated, but I'm sure you guys have experienced these results of momentum. Okay, so I know you guys most of you are athletic, and you're in the middle of baseball, or you were in the middle of baseball season. If I was to throw a baseball, let's say that I let's put Sean in the back of the classroom, and I had a baseball and I had a tennis ball in my hands, and I'm going to throw them both at Sean as hard as I can, but at the same speed. Which of those two balls would Sean try to avoid the most? Okay, he would want to avoid both because I have a crazy hard throw. No, I'm just kidding. Obviously the baseball, right? The tennis ball would probably be less painful than the baseball. It still might hurt, but it's obviously not going to be as painful. Why would that be? You guessed it. Probably that way because there's less momentum because it has less what? Mass. That's right. The tennis ball has less mass than what that baseball did. So if I throw the baseball and the tennis ball at the same speed, it's going to have different momentums because of mass. The baseball has more mass than the tennis ball, therefore the baseball would probably hurt more. Same reason you would try to avoid being hit by a baseball thrown by a professional baseball player. They have been trained, they throw fastballs at 100 miles per hour, 100 miles plus. This is Randy Johnson. I don't know if you guys have ever watched this video before of him throwing a pitch and a bird flying in front. So all these right here is a bird's feathers being exploded. Unfortunately, the bird did pass away. Back to the lesson. I would want to avoid being that bird. I don't want to get hit by Randy Johnson. On the other hand, if this little kid right here was throwing the same baseball, I probably wouldn't try to get out of the way as much as I would if Randy Johnson was throwing the ball. Why? Okay, the baseball's mass is the same, but the velocity of the professional baseball players is going to be much greater than that of the little child. Let's look at another example that I'm sure you guys can also picture. I have this train here, and this train, if it was moving at a pretty significant speed, it was going really fast, the mass of that train is huge. Okay, the train is going to take a lot longer to slow down than, let's say, if I had my, I don't know, a Mini Cooper. Let's say I had them both traveling at the same speed going down the track. And I had the train going and I had the Mini Cooper next to it, and they're both traveling at, let's say, 60 miles per hour. And all of a sudden, there is something on the track and the road up ahead, and both the Mini Cooper and the train have to hit the brakes. Which one needs to hit the brakes a lot faster than the other one? That's right, the train. The train is going to take a lot longer to slow down because it has a greater mass. Now, depending on its velocity, the train could take several kilometers, several miles to stop after it has hit the brakes. But the Mini Cooper, it could hit the brakes within a matter of, I don't know, 40, 50 feet and probably stop just fine, where the train would have to take a couple of miles to slow down. And again, that's due to its momentum, due to its mass. All right, what you guys are going to do now, the assessment that you guys are about to take, you're going to stop the video and you're going to click on the button below the video to go to the Google Doc to take the assessment. You can use your notes. I'm also attaching the last bit of my notes for momentum. But this one is, everything that you've taken thus far is basically a participation grade, but this one is actually going to be a real grade, and it's going to be worth 10 times more than the other little assessments that I've had you guys doing. That needs to get done before Monday, so please make sure that that gets done. I miss you guys. I love you guys. On Monday, I have a lab planned for us where you basically will watch me do something and you'll follow along with the lab that way. Love you guys. Bye.